Live from New York, it's Ask an Engineer.
Hello, everybody. Welcome to another fabulous and colorful Ask an Engineer. We're broadcasting live from the very full of stuff Adafruit downtown headquarters. I'm Lady Ada. I'm the engineer. With me tonight is Phil.
Hello.
On camera control. Just
How's it
us.
going?
Just us. Your
up?
favorite all black wearing hacker engineers.
Yeah, we're here. We took off last week because of Maker Faire and just like straight
Open
up.
Source Hardware Conference.
Yeah, Open Source Hardware Conference. Had a ton of people in town. Pure exhaustion.
We actually fell asleep on the floor.
Yeah, I passed out on the floor. It was a bad scene. But we're back. And
you don't want to fall asleep on the floor because there's like capacitors and like chips and the pins are sticking up. It's kind of painful.
Yeah, I woke up and I did have some
components
wires
sticking out of you.
attached to me. So we're gonna get back to business here. We have a jam-packed show. It's gonna be super fast. We're gonna try to get to everything tonight. Do you want to talk about what's on the show?
Wow, we've got so much on tonight's
show.
First up,
on tonight's show.
I thought you wanted me to talk about it. We have A to Z.
Yeah, the code is A to Z. We have the Show and Tell Roundup. We just switched the way we're doing Show and Tell. It's Electronic Halloween. Ooh, Electronic Halloween. I'm going to talk to you about the Streamy Awards. Need your vote. A couple jobs needed for Jobs Board. I'm catching up on these. Got an Ask an Educator. Got a new section on the Adafruit site for products. Got some mailbag. Ada Initiative. Open source hardware news. Lots of news there. New stuff in the Adafruit learning system. Raspberry Pi news. Big announcement, the Raspberry Pi Web IDE. We took a little trip to Google. Went to Maker Faire. Saw lots of cool stuff, including this guy.
Whoa.
Maybe a little bit of this guy, too.
Whoa.
We got new products. We got
lots of
tons of stuff. So many new products. We're going to have a little bit that's not out yet. Oops. Hit the wrong button. We're going to have some top secret stuff. We're going to answer your questions. We're going to have a trivia question.
We have a lot of videos.
We have a lot of videos. We're going to have a cat.
Oh, cat.
All that and more on Ask an Engineer.
The cat's going to be really close.
Yeah.
Watch out.
Okay.
Close cat. Okay.
This is going to be a packed show.
We're going to do the show. Do the show.
Let's go.
Okay.
All right, so the code is A to Z.
Why?
Well,
Z.
Well, we do a code. We do a 10% off code every week. This is A to Z. And it's 10% off many things in the Adafruit store, including one of our new products, which we'll get to in the new product section. But our coloring book is out, and it is gorgeous.
Yay.
And it's beautiful.
You started the coloring book on the show 2 years ago.
Yeah. Yeah, I was like, oh, it's only going to take like 26 weeks at the absolute most. I'll do a letter a week, and then it'll be done. 2 years.
2 years ago.
2 years ago.
Turns out it takes it per month.
Yeah.
But
so,
you did it.
Yeah.
We did it. We all did it. We have them.
Yeah, we'll talk about that soon.
Yeah, we have one here.
All right, so first up, we just did Show and Tell. Show and Tell changed a little bit. Show and Tell is now on the Adafruit Industries Google Plus page.
Yes.
And we did that for a specific reason.
Why?
Oh, good question.
Z.
Yeah. Because there's going to be more Adafruit staff running the Show and Tells.
Yes.
So Becky is probably going to have a wearable one. Matt will probably have a 3D printing one. Phil B will probably have an LED one. So as we keep adding more people that have specific types of projects, we'll do different themes. And this is the way we can distribute it besides just being off your account.
Can we be like the Fantastic Four, except like I have a soldering iron and Becky has like wearable stuff, and then Matt is like a 3D printer, but he can like turn into a 3D printer, and then...
I mean, we already are.
Okay.
Yeah.
Can we have a comic book?
We already do.
Oh, right.
Okay. All right. So let's talk about what was on the Show and Tell.
Show and Tell,
3 things.
Show and Tell was short but sweet. We started out with Phil B, now known as Evil Phil B, who had a really cool... It's actually not out yet. It's actually like half of the show.
Yeah, we're gonna show a video from Phil at the "It's Not Out Yet" segment.
Oh wow!
So basically, what he has is
a voice changer.
A voice changer. We have a new awesome microphone breakout board.
Yeah, it only took me 2 years to do this board.
Hey, look.
Hey, all good things take 2 years.
We all have goals, and so that's gonna come out soon.
So I was like, do something cool with it, and he's like, okay, I'm gonna do a voice changer, and he did. It runs off an Arduino, and it samples the microphone. And changes his voice, and so he can sound like Darth Vader or a monster or a demon or like a chipmunk.
Yeah, no,
it's kind of cool.
It's super cool. So we're gonna show that video at the end.
Next up.
And then Cecil showed up, and he started a project. He's doing research. So there were people who took the Raspberry Pi and jammed it into like a high-end Canon camera.
Yeah.
So you can do lots of neat camera stuff with it. You know, $35 Linux computer controlling a inside of a camera.
Yeah.
So he's reverse engineering some the Nikon stuff
yeah.
because there's Windows control software that goes over USB. So he's going to try that out, and he's using our Occidentalist distro.
Yeah.
And then Becky Stern from Adafruit stopped in, and she showed some Flora stuff. She's using the Flora with the Flora GPS with the LEDs because we're doing some testing right before launch now.
Mm-hmm.
You can hold up your Flora. So
I was just testing mine.
The Floras were communicating, as they say.
Bleep, 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 bleep.
Yeah.
So I did my pixel test, but she had some pixels, and she has the Flora GPS attached, which we're beta testing, and we're going to try to do a little mini project. Hopefully, this will come back next week with an update on this project.
Yeah. So anyways, the show and tell is every week. For the folks who show up and show something, we have these stickers now that we can send out. We gave some stickers away at Maker Faire. We'll get into Maker Faire in just a minute. Since this is the first week of doing this, normally you tell people how to join the show and tell. This week I'll tell them. So basically, every single week on the Adafruit Industries page, you'll see a post that says, hey, tell us about your project, or just do a comment on a specific post, and we'll add you to the show and tell circle. We're going to send messages. Well, actually, you're going to send messages from your Lady Ada account to all the show and tell people to tell them to make sure they migrated. There's no way that
we can't move circles,
you can't move circles, which makes sense because what you wouldn't want is a private individual like you being able to add a bunch of people as a company. I like that. I like that policy because what you do is you want people who add a company like Adafruit.
How long have we been doing the show and tell? It's been like two years?
Since the second day. No, it hasn't been. It's
a year and a half?
I think it's only...
It's definitely been a year.
I think it's been about a year at the most because Google Plus is just this year old.
Oh, really?
Yeah,
okay.
I think so. I'll have to take a look at that. But we've been doing this ever since they had the ability to do a show and tell.
Yeah.
We did it. We were piping it through Ustream, and then we were recording it manually. And lots of new stuff ahead. We'll actually talk about that. We had a meeting with Google. Okay, next up. We're moving right along.
It's October.
It's October, so that means it's Electronic Halloween. Electronic Halloween, I like Halloween because I think it is the maker holiday.
Yes.
Because everybody can do something. And Halloween is one of those ones where if you showed up with a costume that you bought, you know what? Ain't cool. What you really need to do is make a costume.
Yeah.
And so for Halloween, like, makers really shine. So that's going to be one of the things you're going to see this year. Everyone kind of outdoes themselves. I ran like tons of Halloween contests at Make. This year at Adafruit, we're just going to do a post every single day. Mm-hmm. And we're pleased to announce, we're going to do the first ever costume contest over Google Hangouts Live. So we'll have more details, and we're going to have the Adafruit staff. We'll probably be dressed up in some way. Or we'll probably just kind of look like vampire-ish like people, like we normally do. Yeah.
I'll have purple hair.
Yeah, and we will have folks on the show and tell to show their costumes.
Okay.
I think it'll be the 27th. I think that's the date that we worked out, or something like that. So.
Cool.
Anyways, more about that later. We'll do contests and prizes and all that. We figured that would be a great night, so people can like practice with their costumes on the show and tell. That'll be fun. Okay. Next up. There's this thing called the Streamy Awards, and someone nominated us, and then it got tweeted, and so we did a post about this. Basically, just search for the Streamy Awards, and what you do is you put ask_an_engineer, and then put Adafruit as the Twitter name, and then hit next. And if you're on Twitter, it'll tweet vote for Adafruit. So, it's kind of... as a company,
and this is for the show and tell, or for
this is because we have a live streaming show every week, and they have a show and tell one, and like I think we have a shot because we're the only live streaming how-to and electronic DIY like show every single week. So vote for us because that means that other people will be exposed to the show.
Yay,
and
more people.
It's always fun to get noticed for doing this every week. So if you guys have time, vote for it. It is a challenge as a company now because every time there's anything, the people who run anything, like the entrepreneur contest where you got nominated this, it's a challenge because you really have to ask your community over and over and over again, hey, can you vote? Hey, can you do this? And luckily our community is really into it, so we're lucky.
Yay.
They have all these social media tools, and they're crazy to click something. So anyways.
Okay.
Next up. Because we have we were off for a week because of Maker Faire.
We double the
there's
double
three.
The
there's
jobs.
The job boards on Adafruit, adafruit.com/jobs. Awesome jobs, and it's almost like 100% matchmaking here.
Yeah.
We'll do the Adafruit dating site later.
Wait, what?
But this is HONEYBEE Robotics. They're
Yeah.
looking for a spacecraft. I'm sorry, they are a Spacecraft Mechanisms Corporation. They're looking for a systems engineer.
Yeah. So Dustin, who wrote our awesome robotics book, works or worked at HONEYBEE, so that's cool.
Yeah.
So they hire good roboticists.
Yeah. And then next up, senior mechanical engineering position, and then a platform engineer at Siftio.
Yeah.
So
if you like making little LCDs, play games, then you should go there.
Okay. Next up, AdCap, Ask an Educator. How can I measure AC voltage with my Arduino? Excellent article on how you can measure AC voltage. Now, why would you want to do that? Maybe you should talk about that for a second.
There's a couple reasons. One is that maybe you want to do like power monitoring. So AC is what comes out of your wall. So it's actually not easy to measure AC voltage, especially safely. One is because the AC voltage from the wall is 120 volts. So it'll just fry anything that it touches. It's microcontroller based. So there's a couple ways to do it. You can use a current transformer, something that clamps on to the wire clamps over it and it acts as a current transformer, or you can use an actual voltage transformer. Like if you just want to measure the volt peak to peak, so you use an off-the-shelf transformer to transform it down to say 6 volts AC and then rectify it. The tweet-a-watt is kind of the hack that we did to avoid this problem of it's really hard to do it safely.
Yeah.
So the cool thing about the tweet-a-watt is it has wireless, and so you never actually end up touching the AC voltage. Because it's even though it's floating and it's a high voltage thing, it's encased inside of a plastic box.
Okay, we're gonna keep moving right along. This week, new site category: Young Engineers.
Yay!
So on the product page, left-hand side on the Adafruit site, Young Engineers. All the stuff for young folks who are getting into science, technology, engineering, art, math, all that good stuff. Check out all the things there. Mailbag this week. Packet.
Brings you 2 mailbags because it's been 2 weeks.
Yeah.
All right, first up.
First up, this one is Peter. I just want to let you know how much I liked your packing job on the soda and a pan of ice along with some other bits, and you shipped in the original box after inserting the other items. I really appreciate you not sending a box within a box. We try to do minimal packaging here, so when we have the opportunity, we do that. Thank you so much for sending that in, Peter. Next up, this one's from David. I want to let you know my robotics club is impressed how quickly you're able to help me remove an item from my order. In the future, I'll check your site first for my parts. Thanks again.
Yay!
We try to move fast. Sometimes people they need to add something, or sometimes they need to remove something. We're pretty fast on this, and we're only getting faster. Next up, if you want to donate to the ADA initiative, this is supporting women in technology. When you do, you get 10% off Adafruit stuff. So if you're looking for a good cause.
What is Ada Lovelace Day? That's coming up soon.
That's coming up soon. We'll have lots of details on our site.
Definitely in the fall, but
and then this is the ADA initiative. So lots of efforts to get more women celebrated in the world of science, technology, and engineering. Next up, some big news in the world of open source hardware.
Oh, well, of course, there was the massive event of last week.
Yeah, so I've got a few things to go over with this.
Okay.
First off,
let's check out this cool bike wheel.
Someone put the open source hardware logo on the.
That's actually the perfect thing for a Spoke Pop. A lot of people try to do really complicated graphics, but it actually is because it's moving. The bike's moving. It's best to use it for stuff like this logo or Biohazard or something. Yeah, that's kind of nice. Yeah, so that's a good logo.
And at this point, I think it's okay for me to talk about this. So behind the scenes, there was a question about the open source hardware logo. I went over this a long time ago. Just to catch people up, back in 1999, I designed a logo at the top. 2006, the Open Source Initiative has this logo. It's pretty much my logo. And then
it's green.
Yeah, and then 2011, there was a community design logo in the open source hardware world, which is a gear logo. And then Open Source Robotics Foundation 2012 have their
I really like this
nut and bolt article.
I like it because it looks like a gripper.
So anyways, last year there was a question about the gear logo and if it was okay. So I emailed the OSI. They said it was okay. And then they have a new board that came in.
You emailed the president and the lawyer.
And then this year they have a new crew of people. They're like, hey, wait, like we think the gear logo might be too close to the OSI logo. And I'm like, guys, we've already asked about this last year. By the way, your OSI logo happens to be like my logo. I showed this off at OSCON. We should probably not get into that. I like that you guys have it. It's all cool. Anyways, the whole goal of the last 3 months was to have the OSI and the OSHWA, the Open Source Hardware Association, get together and sign a coexistence agreement. So basically everyone agrees that hey, this gear logo is cool. You guys aren't going to use it to promote open source software, and we're not going to use this gear to. We're not going to use our thing to do hardware. Basically,
it's weird because they both actually have exactly the same values.
Yeah, basically, when foundations in the open source world get together, there's always questions about trademarks and all this stuff. But it seems like it's perfectly resolved. I believe this was announced at the Open Source Hardware Conference. We had to duck out at the end. But it looks like it's all finally done. It's resolved. Everything's cool. So, yay, everybody who chimed in and participated in that. Everyone had goals, and there was mutual benefits for everyone to work together. So it's over. Okay, next up. That was all at the the Open Hardware Summit, which was last week. These were the badges. We have some photos. We had some live blogging going on. Chris Anderson kicked off the conference talking about the maker movement, open source hardware, and how some companies are becoming bigger companies. Yeah. And some of them are releasing some open source hardware. Some of them aren't releasing all of it as open source hardware. Mm-hmm. Lots of different sessions touched on the business side. Lots of sessions touched on more of the tactical side of releasing open source hardware. So Woz was there. Amanda Woz Wozniak did an excellent presentation. Had lots of kudos because it was really nitty gritty about taking your design
from manufacturing
to manufacturing.
Yeah, so it was about manufacturing, manufacturability. This is actually what's interesting is it's actually a really important talk, especially as we're starting to see more and more people do open source hardware projects and put them on Kickstarter. And designing one-offs is really, really easy. I have a couple years experience in this. It's very, very easy to make the first one. Yeah. And it's very, very hard to take that and even make 1,000. Yeah. And then it's even harder to make 10,000 or 100,000. So, as people are starting to do projects where they have a prototype and then all of a sudden they have to make 10,000 of them, watch her talks and listen to what she says because it's really important. And making a good decision early can save you a shit ton of hassle, effort, tears, frustration, and money.
And so watch Woz's talk. Might have to slow it down. She talked super fast and she jumped knowledge. So
knowledge was dumped.
All the links are on the Adafruit blog. Yeah. My favorite talk. I'm just gonna Woz's talk. Of course I'm gonna say hers is my favorite, but one of my favorite other talks besides Woz. Was Akiba, who talked about how open source hardware actually, and I'm just going to paraphrase a little bit, it actually did change the Japanese government because they went around and they made open source radiation detectors that detected the actual amount. So he has videos of a playground that after the disaster there, they said it's totally fine, and this thing was complete. The
video was incredible because he actually had a radiation detector with him. And if you turn on your standard alpha, beta, gamma radiation detector on, it'll go beep, 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 every couple seconds. It'll tick just because there is background radiation and things are radioactive here. And then at this playground, he turned on the radiation detector, and it just went beep. And they contacted the factory. And
said, I think it was farmers though. I think the farmers had one, and they said it was there's something wrong with these
because this keeps beeping. It doesn't stop.
It's one long solid beep.
And the guy and the radiation detector company said you have to get out of there immediately.
Yeah.
There was so much radiation that it couldn't even differentiate between.
So do watch this talk because this is kind of the future. I believe citizen engineers are going to be the ones that are going to look and see what actual radiation fallout happens when disasters like this happen. I don't think it's even possible for a country, a government, to do this accurately. You do need to crowdsource it, you do need to have people that are living there with open source equipment who can put this together and then share the results. Anyways, this is a goodie bag, and we're going to give this. It's filled with stuff. We're going to give this away tonight as a surprise. It's here.
Whoa.
Yeah.
Totes open.
Yep.
Look at all these goodies.
Yeah, lots of goodies. There's tons of stuff in there. Okay. Next up, the OSHWA, they announced that the membership is open. This is the organization that has people in the open source hardware community that now there is a real org that's representing all of us. So they're out there, and they're going to be promoting open source hardware, educating people about it, including this very first public service announcement.
Oh, that's a great video. Yeah, let's show the video.
Let's show the video.
What is open source hardware? It's a physical item whose source files have been shared openly with the world and can be freely copied or modified. In the open world, it's not about reinventing the wheel. Anyone can improve and build upon the ideas of those around them, and innovation is accelerated through the open exchange of ideas. Rather than starting from scratch, open source hardware allows you to modify a design for your own project or even turn it into a business. In 1817, a two-wheeled machine called a draisine was invented. It was made entirely of wood, propelled by walking, and designed to ease travel across the royal gardens. But because people saw hundreds of ways to make that machine work for them, over the past 200 years they modified the prototype, adding useful things like pedals, rubber tires, gears, chains, and durable metal frames. Over time, our international community took a simple machine's original design, shared their ideas, and customized the modern bicycle to suit the needs of 1.4 billion people around the world. This collaboration is what the open source movement is all about, and its ideology has the potential to shape the future of how our society does business. In a world fueled by open contribution, companies can no longer rest on intellectual property. This allows the open source hardware world to quickly find the most efficient and fastest producers for physical goods. On a level playing field strengthened by community input, companies will be distinguished by their adaptability and the quality of their products. By opening progress to the public, we put the catalyst for positive change in the hands of those who care about it most, and we can begin to see innovation driven by passion and equality. That's where we come in. The Open Source Hardware Association recognizes a need to improve the way we work together to revitalize collaboration at home and around the world. We want to show people that sharing ideas makes for better ones, and that open source is a smart and sustainable path to a stronger, happier community. What will you share?
Really? No, that's the end of it now. There it is. Okay. We're going to keep moving along. So that's the public service announcement. Do check out OSHWA.org, and if you like open source hardware, become a member.
Yay!
Get involved, join the mailing list, all the good stuff.
Okay, next up.
Adafruit Learning System, we have some updated tutorials. You ready?
Yes!
Go. What tutorials are in there?
This tutorial is these are updates. So this is the tutorial on how to interface a computer or microcontroller to a shipping scale. It's really handy if you want to weigh stuff, and with a microcontroller, these have RS-232 output. So I talk about how I reverse engineered it and connected to the shipping system we have here.
Yep.
Matching that, we also have a little tutorial about barcode scanners. We also use barcode scanners, especially these really nice LS2208 symbol ones. They're super fast and super accurate, and they're also super easy to interface, and I have some Python code for interfacing them. We also have a great, lovely little tutorial on using our...
21 gigawatts! 21 gigawatts! Okay, sorry.
What the heck was that? Using our 7-segment LED backpacks together, and he made this kind of cool, like, wearable Back to the Future clock thing. We also have a tutorial that we put up, actually it's a while ago, on how to use the real-time clock on an Arduino with the 7-segment display. We also have an update to our LED backpacks to cover the new 1.2-inch backpacks.
Okay, next up, some Raspberry Pi news.
Pi.
Every Friday on Adafruit we have Raspberry Pi Day. Do check out all the posts relating to Raspberry Pi.
Friday is Pi Day.
Friday is Pi Day. We met with Evan and Liz. There's Lady Ada and Evan and Liz from the Raspberry Pi Foundation. We went to this awesome Korean food place.
Yeah, we had Korean barbecue, which I've never had before, and it was really good.
It was really good. It was great to meet them in person. We talk to them all the time, so it was really good to discuss all the stuff that we're doing with Raspberry Pi, all the stuff that they're doing, and our joint kind of education mission to help teach the world electronics and programming. Yeah. All using a cool thing like the Raspberry Pi.
It's all good news.
Yeah. Next up, the Raspberry Pi badge was added to Adafruit Academy. Check out Adafruit Academy. It has all the requirements docs if you want to award kids, adults, anyone.
Your pets.
Your pets.
I don't think your pets if they can
anything. and anyone can earn a badge.
Yay!
Okay, the big news this week was the Raspberry Pi Web IDE. It's making the rounds on the web right now. Lady Ada, what is a Raspberry Pi Web IDE from Adafruit? What is this thing?
Yeah, so we released this on Friday, and yeah, it's really exciting. We talked about it before, and we finally actually have an alpha out. The alpha is it's a little bit buggy because, of course, nothing finds bugs like 5,000 people downloading your software and all installing it on weird versions of their computers and stuff. But basically, the idea is I wanted to have an IDE, but it's not really. It's a very basic IDE. It's even simpler than the Arduino IDE, and it's designed to run on a Raspberry Pi, and you connect to it hosted on the Raspberry Pi through a web browser. So the idea is that you can have your Raspberry Pi for making electronic projects, buttons, LEDs, playing music, any kind of electronic microcontroller type project. And then all you do is, instead of having to SSH in, and then you have to install Emacs or whatever, and you have to learn how to use Linux, instead you can connect through the Web IDE, and then we'll slowly have tutorials that go with the Web IDE for learning Python and controlling digital inputs and outputs, like LED strips or LED backpacks or barometric pressure
It uses
sensors.
Bitbucket so it can take all the code down.
So
that's a big part of it.
So the cool thing is that it's hosted on the Pi, which is great because it means it's self-contained, and the Pi itself is hosting the web server. It uses Node.js, which is awesome. But one of the things we were a little concerned about is, well, what happens if somebody accidentally breaks their Pi? Because this can happen. You can pull the SD card out. You can give it really bad power or fry it. And we don't want somebody to have written all this code and then they lose it. That would suck. So the reason we decided to go with Bitbucket is, first off, they're totally awesome. They're a really great online code repository. And you can have, it's very easy to sign up for an account, and you can have a private repo, which GitHub will not let you do if you have a free account. And so we went Bitbucket, and the owner of Bitbucket totally loves this project, and it's awesome. And good, all good. And what happens is that when you log into the Web IDE, even though you're writing code, and the code is all local on the Raspberry Pi, you don't need to use Bitbucket. By using Bitbucket, all your code is synced online to their basically the cloud, their servers. So if you end up frying your Pi or somehow destroying it or accidentally deleting all your files, it's okay because they're all stored in a Git repository basically on the back end. And so you also have full revision control as well.
Where is the code compiled?
The code is all compiled locally. Everything is handled locally. The only reason you need to connect to Bitbucket is when you do a save, it pushes the code so that you have a backup. Basically, it's an online backup system. Yeah. But it's also really handy.
It's super clever. I'll tell you why I like it. Just for the folks who aren't into this yet. I'll tell you why.
Yeah,
okay. I know. You
biased.
have to be. Well, first we shall say big ups to Justin and Tyler who just rocked us out. Daigo, Lady Ada, everyone involved.
Greets.
Yeah.
They rocked it out.
Who did this? But let me tell you the big thing with this.
Okay.
$35. This goes into a school. They have monitors and keyboards, internet connection. Kids are learning Python.
Yeah, so
I mean that's actually the big thing. It fulfills the promise of a $35 low-cost computer teaching programming.
Python, but also I think Python's interesting, but the problem with programming, and I mean I of course I program a lot, but I'm an electrical engineer. So the thing that I find boring about programming is it's you're now I'm adding numbers, now I'm printing hello world, and then it's what do you do next? I find that programming, it's very easy to start, but then you start, but then there's this huge gap until you can do something interesting. Yeah. Right? You can make eggs and milk minder or whatever, but then then what do you do? There's a big leap between that and I'm writing a game for the Xbox.
Yeah.
But the cool thing about electronics and physical computing, the way people use it with Arduino or MSP430 or BeagleBone or whatever, is that you start with LEDs and buttons, and then you can quickly do really fun projects. There's a nice continuum, which I feel you don't really get. With Python, you're just you end up just now I'm doing linked lists. Who cares? It's not interesting.
I'll tell you what I like. Within
Whereas
15 minutes,
computing is fun.
A kid could potentially do a light painting. That is unreal. Plugging in a Pi, getting the Bitbucket repo down, changing some stuff, or adding an image or whatever, and then walking outside and then doing a light painting. That golden time, that half an hour or so, I mean, that turns someone on to programming and electronics for life. Look what I just made.
Yeah.
Look what I just did. It's insane.
So, yes.
Awesome.
So the thing about the Web IDE and my thinking behind it, and I've been actually thinking a long time about this, and I wanted to make something where there was no drivers, no software to install.
Yeah.
I mean, yeah, you have to install the software on the Pi, but I mean, eventually we're gonna have SD cards available in the Adafruit shop, and you plug it in, and it just works. And like, you know, if you break it, you'll have to burn it. But we'll have tutorials on how to do that. But you don't have to like download an IDE and install a driver, and then like which COM port. Like, I wanted to like skip all of that. And it's like if you're running Occidentalist, you plug it in, you open up your web browser. Everyone knows how to do that. You go to raspberrypi.local:3000, and it's there. Like, you're done. You just log in and you're ready to go.
Yeah.
And it's like the easiest way possible to do physical computing and learn programming.
Yeah.
So I think it's very interesting.
And as usual, it's open source because it's from Adafruit, so
Yay.
you can get it on GitHub if you want to muck around with the source code
and
make
pull
it better.
requests.
Yeah. So, all right, next up, we had a lot of visitors in the Adafruit headquarters.
K-Town.
Kevin was in. Rick and Bill.
Rick and Bill.
Robot Girl.
Robot Girl. And Robot Bird.
Robot Girl again.
And Robot Bird.
Super awesome Sylvia.
Super awesome Sylvia. Is getting taller than me. I don't like it. She's gonna beat me up.
Adabot, Sylvia, Lady Ada.
You can kind of see MOSFET. I'm holding MOSFET.
Yeah.
Or he's holding on to me. And it's super
She's
awesome.
beta testing the circuit playground.
They're squishy.
Yeah. And then speaking of Adabot visited Google.
Yay.
Google wanted to talk to us about all the efforts. We brought our entire team out. Adabot, Becky, Lady Ada, Tyler, Matt, Kevin, all went to
Google HQ down in Chelsea.
Yeah, and
they have a big building.
Yeah,
I mean,
there's like 8 cafeterias.
It's kind of like it's kind
intense.
of unassuming, but it's massive. It's near Chelsea Market. Or is it above Chelsea Market?
Yeah.
Yeah, it's in the same.
It's
building.
like it's across the street.
Or across the street.
Yeah.
Yeah, sorry, it's across the street.
Yeah.
It's huge.
It's intense. And
I think they bought the entire building.
Yeah, they have a lot of floors in it, and we basically talked about all the cool things that we're doing with Google Plus and Show and Tells and Hangouts.
Yeah.
And we'll have some big announcements soon with what Adabot, our, Elmo for engineering, I'll do quotes like that, is going to be doing on the Show and Tell soon.
So we brought all of our goodies.
That
was fun.
Yeah, what's neat was to basically do a puppet show at Google.
Yeah.
Didn't expect to be doing that on a Wednesday, but we did. Okay, next up in the world of making, and I have another short video because we're going to try to grind through all these. MakerBot opened up a store.
Oh, yeah.
Yeah.
Well, I can't believe this all happened last week.
I know.
I was like, that was a month ago.
Yeah, no, it's last week. So we
week.
have a video tour of the new MakerBot store. We ran down there, and Bree happened to be there, so here's the video. Okay, here's Bree at the MakerBot store.
Hey, Adafruit folks. We are at the MakerBot store. Come on in.
The video's not playing. It's just like a slideshow.
It's stop action.
We've worked really hard to make a new machine, and we've also launched this store because when it comes to 3D printing, it's so good for people to be.
So the video's on our site, and you can check it out.
Yeah.
Ustream doesn't play the video.
So, but it was cool. So check it out. Basically, we went to the MakerBot store, which is in NoHo, just barely. It's actually off Houston, so it's actually like really cool. It's across, I think, from the REI.
Yeah.
Near the REI, and it's in a fun neighborhood with some really good Thai food. There's a really nice Thai food.
Yeah, we'll probably try to do an Ask an Engineer from the MakerBot.
And it's a gorgeous boutique.
Yeah, we thought we have some fun ideas. We'll maybe talk about that.
And there's
later.
like 8 MakerBots replicators, and they're all like replicating. And there's a lot of really happy, friendly people there to talk to you all about replicating and MakerBotting and 3D printing. And you can also buy some MakerBotted stuff there, but I think mostly just because people are always asking to, oh, can I buy this watch or can I buy this thing? But for the most part, it's just cool. It's just showing off the 3D printing. It's beautiful. They have all the plastic, all the colors of plastic.
Yeah.
And they have little, not little arcade things, the little quarter, what's it like, gumball machines?
Yeah.
And you can get like little miniature MakerBot stuff. So that's really cool. It's very exciting and it's new.
Yeah.
It's definitely like a go-to place if you're stopping in New York.
If you're in New York City, go there. I believe you can just walk in and buy a MakerBot.
You can. I think they will.
Walk out,
I think you can go in there and you're like, I need a MakerBot right now. They will actually sell you a MakerBot.
Okay. Next up, Maker Faire was this weekend. Last weekend, sorry. And
we were there.
In New York City, they declared it Maker Week.
Yeah, actually, check out the declaration. It's really cool. So Bloomberg, the mayor mayor for life of New York City, he was an electrical engineer. He studied electrical engineering, and his company Bloomberg, they made these terminals, and he basically made his fortune off of engineering these terminals.
Yeah.
And he talks about how he was soldering the capacitors onto this board on the back of a cab to make it to his demo, and how he thinks he really loves makers and engineers and stuff.
Okay, so we're going to do a quick photo tour of Maker Faire. We tried to take a bunch of photos, but we're just going to go through these really quick.
Yep.
First up, congratulations to our friends at Element 14. They won a Makey Award for Best Community.
How many Makeys are given out? I don't know, 5?
There's, I think, there's like 10 categories. Okay. So 2 big ones this year, kind of newcomers on the scene. Element 14.
Yeah.
Best Community stuff, and then I'll remember this. The hackable gadget, the Raspberry Pi. I believe they got this
that's
one.
Matt Richardson.
That's Matt Richardson. Here's you. You were at the Hackerspace Village. You went and visited all the hackerspaces. We did this great program with hackerspaces where they get discounts the same as resellers. So it was nice to meet all these folks in person. Here is Matt Richardson doing a Pi talk. He was showing some sample chapters from his Pi book. Here's some young folks, some makers, some posts from Matt Richardson.
Just cool.
I'm sorry, Matt Griffin.
Matt Griffin, yeah.
Yeah, I'm getting my Matts confused.
Too many Matts.
Yeah. Here's Lady Ada and Annie Fresh. Annie is the person who, she works at Sesame Street, but she also made Adabot.
Yeah.
She makes Muppets for a living, and she made Adabot,
so cool.
So she's doing some more stuff
Muppet
with us
Maker
soon too. Here's the Red Bull Pavilion.
This is great.
Yeah, this was the hunt for Red September. This was
Tyler Cooper's project that they did at the Minneapolis the mill.
Yeah, and then there was also this really great Atmel Arduino Pavilion.
Huge.
It was really neat to see.
And they had FAs there hanging out, just answering questions.
Yeah,
and
it's really neat to see Atmel completely embrace Arduino, like fully. It is their like calling card now. Like if you want to learn about Atmels, go check out Arduino stuff. Yeah. Like that's actually how I think they're explaining it to a wider audience. Besides like, oh, you need a chip. Like this is actually like a way because there's so many projects involved. Next up, we got to meet Charles in person.
Yay! I think we have met Charles now.
Not in person.
Okay. Anyways, so Charles is at Miters.
Go there.
And he's at Miters and he makes awesome carts. And we don't even post up every project or blog post he makes because he makes so many. But check him out. It's like either the iPi +1 or something is the name of his blog. And I think he's showing off like his teeny cart.
Yeah. I think my favorite little booth area at Maker Faire was Little Bits. Yeah. Like super cute kids.
Super cute.
Building electronics, learning things, and forever they'll not be scared to start doing electronics. Super cool to watch this. Watching kids build something in a matter of minutes. We were kind of on the lookout to see what people were doing with Adafruit stuff, so the perma-protos were everywhere, absolutely everywhere. People were using them as, they would prototype something, but then it becomes a permanent part.
I don't have time to make a PCB, so
they were everywhere. And then Hackaday had a booth, which was kind of neat because, for maker history, I founded Hackaday a million years ago. Caleb Kraft is someone who now runs Hackaday. This is the first time you met him. First time I met him.
Yeah.
Ever. And I've corresponded with him forever. So here we are, meeting for the first time. And then this is some 3D printing stuff that I thought was fantastic.
These like 3D printing head things.
Yeah. Wearable. Like this was a company that made wearable 3D printed stuff. I thought was really neat.
Yeah, this is cool.
Isn't that cool? And then here's a giant 3D printer. Yeah, it prints out Lady Ada's.
It prints out Ultimakers. Yeah, this was actually a hackerspace. Yeah. And they took the Ultimaker design and they
Here's some guy just checking his email. Nothing, no big deal.
Do.
Yeah. Here's Mark Fraunfelder from Boing Boing.
Yeah.
Anne-Marie was doing this great presentation about young makers and Maker Corps. We ran into our old pal Stephen Wolfram.
I'm doing the W.
Yeah.
You
and Waz and myself met Steven at a food camp.
Yeah.
And he added all the engineering calculators that you and Waz suggested.
Yeah.
And then you ran into him again, and then he showed. He said, "Oh, you guys sent me an Arduino. Give it to my kid. My kid just did a presentation about a quadcopter.
Cool.
Super cool stuff. Anyways, Ian Lesnick from Dangerous Prototypes was there.
He's plaid.
Went to the MakerBot Pavilion.
It was massive.
ran into
There
Bray.
was a lot of 3D printing.
Yeah,
going on
and
there.
I just want to point out, this is a rare thing that happened. A couple wired covers hang out. This is Bree
Oh.
and you, and then here you are here. There is a
He was
possibility.
totally photoshopped.
Yeah. Yeah, and he had a lot of makeup on.
Okay.
Next up, Ben Heck was there from
He
Element
had these
14
cool
New York.
glasses. They of course were in the sun, but when he went inside, there was a little servo and it would lift his glasses, the sunglasses up. So like those little lifty glasses, but it was completely automatic.
Yep.
So he was hanging out.
Ariel from Sparkle Labs, one of our favorite kit makers.
Also in Soho.
Yep. Adam from Wayne Lane, one of our favorite open source hardware companies.
Yay.
They keep it real. We did an interview with the folks at SparkFun. You did.
This is Pete.
It was Ask a Pete engineer. I don't know. Like we combined the two for a little bit.
We had a lovely little segment. It's like 5 minutes long, and they said they were going to show it maybe on Monday.
Yeah, it'll be on their site. And then John Janier had his project there.
Yeah.
This is how he actually does fritzing. This is why he's so good at it.
That's why he gets the details just right.
Yeah. And then here's Matt Richardson. He was showing off his BeagleBone camera that actually can do this neat identification thing.
Yeah, it uses Mechanical Turk to describe the photo.
And of course, Becky was there. Becky had her own thing going on there with the Madagascar group, the Mechanical Bulls.
Yeah.
So she documented it really nicely on the Adafruit site. She had all these things going on. Madagascar group. So that
I like the sign because it says next ride, now, soon, later.
Yeah.
Not for you.
Yeah. Okay, so before we get started into new products, we're gonna have to zip. We're gonna go a little bit late on the show, I know, but we have a lot of new products.
It's okay. I'll demo everything really
fast.
fast.
Yeah. Okay. So don't forget the code is A2Z. 10% off many things.
Mhm.
Adafruit store. And you know what time it is, Lady Ada?
What?
It's new product time.
Yay!
All right.
We don't have a new product.
Working on it. Okay. Let's do this thing.
Okay.
Teensy 3 is out. A successful Kickstarter for Paul.
Yeah.
And then we actually have these ready to go.
Okay. So, I just want to talk very briefly about these. So the Teensy 3 is kind of, it's not even similar to the Teensy 2. It's the same shape-ish. But it uses, it's a Cortex M3 chip. Uses the Freescale Stellaris MX processor. It's crazy powerful. And he also ended up porting the Arduino IDE to support this processor, which is actually really cool. I haven't had a chance to try it out, but it seems very promising. I hope people check it out and give feedback.
Yeah, and there's if you are curious about all the stuff it does, has a chart.
I mean, it's crazy. It does everything.
Okay, next up, Coloring Book is released. You
book.
can actually get it now. It is here. Yeah.
Show on the overhead.
Yeah, show it over on the overhead.
Okay, so on the overhead.
Maybe thumb through the pages.
I will
really quick.
thumb as soon as you flip over. Okay, so this is the lovely cover. It's a nice stiff cover, and then there's multiple pages. Oh, this one's already colored in.
Yeah, Becky colored that one.
Nice work, Becky. And then, all sorts up to Y for Yagi and Z for Zener. And so there's a little bit of text on each one, and then a person who discovered something, or sometimes there's a cat, or sometimes it's mossed it with a multimeter.
Printed in the USA.
Yeah, in New Jersey.
Special,
which is part of the United States.
Yeah. Special shout out. I think John Janier is here tonight. He did some of the text on here.
Yep. This was all drawn by Robert Ullman.
Yep.
Nice work, Robert
Yeah,
Ullman.
David who did the cover. It was a lot of fun. This was it's the start of many types of projects like this for us. Next up, I'm probably going to start doing R is for robotics.
Yes.
So I'll see you in 2 years.
P is for programming.
Yeah.
Okay.
All right. More new products. We're whipping through these. Here is a quick video that Becky did.
Okay.
I'm just going to show a few seconds of it.
Lady Ada's E is for Electronics is a coloring book adventure with electronic components and their inventors. Inside, makers of all ages can learn, color, and share common parts and historical figures throughout history. The illustrations are accompanied by helpful text helping kids learn about everything from Ohm's Law to quartz crystals. L is for Light Emitting Diode, and I had a great time bringing this drawing to life with lots of different colors. We get our coloring book printed in New Jersey at a solar-powered facility using environmentally friendly printing supplies, and it features a full color illustration front and back cover and 26 coloring pages inside. You can print it at home by downloading our free PDF of the entire coloring book. So check it out. The coloring book is in the Young Engineers section.
And as always, you know, we're open source here, so we decided to put this as a Creative Commons share alike unported license. That means you can download this. We actually have the direct download on our site.
PDF.
People have already started doing translations for it. So that's kind of the thing that we're doing.
Yeah, it's cool. I can't wait till we have like 6 different downloads.
Yeah. All right, next up, we have.
Your little color controller for our LED strips.
Yeah, I'm just going to go through these really quick. It's pretty self-explanatory.
Yeah, do you want to go to the overhead, though?
Yeah, we can go to the overhead. We also have a little video.
How about I just do the overhead? We won't show the video because
okay.
It's the same thing. So yeah, it's just the camera's all confused because it's too bright. But there's this capacitive touch square, and you can kind of see it's got a color circle, and so I can select what color by spinning on the circle. It also has a couple different modes where it changes colors and it'll fade through them. And then it's really easy to wire up to it. There's these terminal blocks over here. Here, I'll turn this off so you can focus on it. There's terminal blocks just connected up to a 2.1 millimeter barrel jack, and then you connect the cable up to here, and it can do up to 4 amps per channel. So it's a lot of LED strips. This is really a lovely little thing and easy to mount onto your wall.
Okay, we're going to keep moving. I really like this. This is a Color Forms paintbrush. If you like the Drawdio, you'll like this. And
it's based off of the Drawdio.
Yeah, and Jay Silver, who worked on the Drawdio, is credited on the design for this. We actually have an old photo of something that he worked on. This is like 3D printed version. So do check that out. Like I said, we have to move really fast tonight. Some products in the Raspberry Pi world. We've got the book. We got it a little earlier than we thought. So the Raspberry Pi book that
by
Evan and Gareth wrote, you can get right now. We actually have these.
Yay! It's actually really nice. It covers a lot of stuff from getting your Pi started to doing like LEDs and buttons.
Yeah.
And covers some accessories. It's a hot off the press.
Yep. Next up, these are officially approved aluminum milled cases.
Can I show them the overhead? Because they're kind of cool looking.
Yeah, and there's one with the Raspberry Pi logo and one without. And these folks worked with the Raspberry Pi team, which we always think is important because if you're going to use the logo, you have to ask the foundation, and they did.
So this is gorgeous. It's milled out of a solid block of aluminum. You can see the tool paths a little bit on the inside.
Yeah.
It's polished on the outside, and it's just this gorgeous chunk of aluminum, and it's bright and shiny. It has like mounting holes and stuff, and all these holes. This one's the flat one. There's also a version with the logo on top.
Raspberry Pi is $35, so I figure you're ahead of the game. Spend some bucks on a beautiful case.
Yeah, this case is the most beautiful case, and we're like it is the most. It comes with accessories, it's screws and the insulating thing.
Yeah.
And
so we liked it, so we talked to them. Next up, Evil Mad Scientist has a new kit out.
Yes.
This is the ARC controller kit.
This is it's a little bit hard to explain in detail, so I will tell if people want more details, please check out the website.
It's a relay board. I mean,
it's basically a relay timer control board, but basically solves the problem with people who are like, well, I just want a thing that like turns something on for a few minutes and then turns it off for half an hour. And so this is kind of an all-in-one timer board that they designed for a museum, and also good for this stuff.
Next up. You want to start talking about these?
These are LED matrices. We have more 1.2-inch LED matrices, but I'm not going to show them individually. I'm instead going to show them...
and then we also have...
Yeah, it's part of the backpacks.
Part of the backpacks. You want to just go to the overhead?
Yeah, go to the overhead and let me...
We are going to go to the overhead.
Plug this in. Just give me 1 second. So the matrices are available individually, but most people don't want to do all the hassle of wiring them, so we have a backpack, and the backpack has this lovely chip that we've been using for our LED backpacks, and we use them for the 7-segment backpacks and everything. And this is I2C, and you can connect up to 8 matrices all at once, which is kind of all you probably need. And turn this upside down. So this is the green one, and these are nice and bright. They're constant current, which is lovely. They do all the addressing for you, so you just say, here's what I want to display, and it will display it. So it's the green one, and then reset. This one is the red one. Yeah. Looks kind of nice. And then this one is the blue one.
And how are these controlled? What protocol would you possibly use?
Use I2C.
I2C.
So you can have up to 8 of them, because you can change the address on the back. You can have up to 8 of them connected on the same I2C bus. So you could
you
have 8 in a row and scroll messages across them and stuff if you want them.
Very cool.
And then this one is probably the yellow one. Yeah. So this one is the yellow. It's actually amber.
Yeah.
So Yeah, really bright, really nice matrices.
Yeah.
And you can actually dim them through the...
we do live demos every week. That's worth a streaming alone.
Okay.
It could all go wrong. It's crazy. But it all goes right. Okay, next up. Let's keep moving.
Yeah, so that's the demo.
Moving. Okay, next up, we got frickin' lasers. Look at these lasers. These are photos of all the lasers. We got a laser mount. We got all these laser beams. Look at this. We got lasers that are pointers. We got lasers that are lines.
Yeah.
We got lasers that look like this.
Okay, so let me first show off.
We got a cross laser.
Don't get too excited.
We went laser crazy.
Okay, let me show off the dot laser first.
Okay.
So let's
actually.
Yeah, I'll show these on there. They actually all have the same body. They're round, and this is the part that lasers. And there's a laser diode inside of here. It's these are all 650 nanometer red laser diodes. They're all 5 nanowatts. 5 milliwatts, which is class 3A, which is kind of the limit of what you can use safely. Don't stare at it for minutes, but if you shine into somebody's eyes, it's not going to hurt them. If you do it accidentally, although I wouldn't do it on purpose. And then they're encapsulated with a little driver inside, so you can power them from 3 to 5 volts. So you don't have to worry about the constant current stuff. That's taken care of for you. And this one is the dot laser, and I'm not going to be able to shine it at the camera because, of course, it's a bad idea. So I'm going to shine it down at the whiteboard because you can actually destroy a camera pretty easily by shining.
Really?
The laser. Yeah, because it's too much. You can burn it out. So this is the red dot laser. And this one's pretty simple. It's just, a dot.
Yeah.
Okay. So it's a nice dot. This one's the least expensive because it's pretty simple.
Okay.
And you can do a little bit of focusing. There's a little focusing thing if you want the dot to be a little more focused.
All right.
Okay. Next up, we have a cross laser. I'll show that next.
And I'll hit the photos while you're plugging that in.
So this one, I'll show. This one has a lens. Oh.
Yeah, that's what it looks like when it's going.
This one has it's hard to see, but it has a little lens in it. And what it does is it's kind of like a diffraction sort of lens, or whatever. I don't know exactly what I think diffraction is the right word. And it turns the line into a cross. This might be good for like targeting or vision, because this way there's more something for the vision system to grab onto.
Yeah.
And also you can detect if something's twisted, because as it twists, it's not level. Yeah. And you can also use this as if you want to measure 90 degrees. This can be used for that.
Yeah.
So I thought that was kind of cool.
That.
Okay. Next up. I'll have to find where I put down the line laser.
Could these be used with a photosensor?
Yeah, the dot one would be the best one for using the photosensor because it's a dot, and then you can use a phototransistor photosensor. You can use it for like a tripwire type thing.
That'd be fun.
Or like a laser harp or data communications. I'll show the TTL one last. And then this one.
This is the line one, right?
This one also has a diffraction. You can kind of see a little bit. This has a little diffraction lens in it, and so this one is a line laser. And a line laser is kind of interesting, and the reason we actually wanted this one the most rather than the dot, because the dot laser is not too exciting, but the line laser, what you can use is you can use this to do 3D scanning. Yeah. So as something passes through the line, you can use a web camera to pick up the very bright line if you're in a dark room, and then you can do some basic 3D scanning using only a web.
Yeah, we'll have more about that later.
So yeah, check those out. I mean, if you look for laser webcam 3D scanning, you'll see projects on how to do this. And a lot of them, you need to get like a prism or a lens, but this is nice because it's you just plug it in, you're ready to go. Okay. And then finally, we have the TTL laser, and so this one has a blanking line. So this one, it basically looks just like the 5 volt, but it has 3 wires. It has red, black, and yellow. So you can connect it as normal, and then the red and black are power, and then yellow is for the blanking. So when this is connected to 5 volts or 3 volts, I think that's the range, it'll turn on. And so the reason you want to do this is it's best to control, if you want to do like a laser light show or communications, like you want to transfer data using laser pulses. Yeah. It's better to power the laser continuously and then blank it. Yeah. To get
as
really
opposed
good pulse
to
width.
Turning it on and off.
I don't think it's bad for the laser. I think if you don't get very consistent pulse widths, you don't know it's not going to be as consistent if you use the blanking line. So one of the projects I want to try doing is getting some galvos and maybe trying to do a basic laser light show. And so that's what blanking is good for, so that you don't have a line connecting everything. So yeah, we'll check out some cool laser projects shortly.
And then we have a mount. You want to just show that really quick?
Oh yeah, the mount's pretty simple.
We gotta move.
Yeah, this is just a you can slide your laser in here, and then there's a set screw, and it's set right now. But you can slide this through.
Yeah, and I guess I should kind of tell you the usual. We have a giant box full of all the ones that aren't great, that don't meet Adafruit's kind of seal approval. We think these are great. We got them at a great price.
This isn't loose, but this can tilt up and down. So you can attach this, and you have a little bit of, just really here, and then this tilts up and down.
Okay.
So
that was new products, and we're going to keep moving. Whew.
Does it?
That was new products, yeah. We probably forgot one, but anyways. All right.
Oh, yeah, you know what we did? We forgot the...
What?
These guys. Did you want to show these off, or maybe next week?
Yeah, real quick. Sorry,
Okay.
one last new product. We got heat sinks.
We got these little mini
Let me just say something. You don't need these for the Raspberry Pi, but everybody still wants heat sinks, so we carry your heat sinks.
Well,
you can use them for other stuff.
We carry them for other stuff too, but actually Woz actually asked us to carry these lovely little heat sinks. So we have 3 sizes.
Yeah,
this
they're
one's
super cute.
a 1/2 inch by 1/2 inch, and they're flat on the bottom, and then you can use thermal paste or thermal tape to attach it to your sock or your ASIC or your FPGA or anything that you need to cool. This is for surface mount stuff. We also have a 0.4 by 0.4 inch one, good for medium size.
And this is just to cool down a processor so it operates at its ideal condition.
Well, sometimes you have like a motor driver or something, and like those chips, it's like they come in QFN, and if you have a 4-layer board, or if you have a an aluminum base board, you can heat sink some of these things. But sometimes you need a little bit more. So these are like heat sinks that are flat. They're just easy to attach to chips and stuff. They're designed to be glued or taped onto.
These are super tiny.
So
too. They're nice.
Yeah, this is the smallest one, but they're all really good.
We got to keep going.
All the cool innovations.
All right. So, anyways, that really was new products. I mean it this time.
For reals.
For reals. Okay. So next up, we're gonna do It's Not Out Yet. We got a couple short videos. We got some stuff going on here. The very first, most important one is a special video from Phil B. Here it is. Watch this. It's going to be a lot of fun.
Wow, it's October already. You know what that means. Columbus Day. No, Halloween. All month long on the Adafruit blog, we'll be showcasing your electronic Halloween projects. Here's one of ours to get you started. The Adafruit Wave Shield lets you easily add sound effects to any Arduino project. Just load an SD card with some wave files and write a little bit of code to trigger these based on buttons or other sensor inputs. You could add sound effects to your candy bucket or your costume. Or your dog's costume.
Hi there. My master made me this collar so that I may talk.
And we have a new treat this month too, the Adafruit Microphone Amplifier Breakout. This lets us add audio input to an Arduino project, just like the Wave Shield gave us audio output. And there's a trick too. We can use the two together and make a real-time voice changer. It's perfect for Halloween.
Edgar, this is your tummy speaking.
We represent the Lollipop Guild.
Do not underestimate the power of the Force. Daisy, Daisy, give me your answer, do.
I'm only 3.5 years old.
I'm a scary monster. Roar!
Now when you have something cool to share, remember to use the Show and Tell feature in our Circuit Playground for iOS. You might see your project showcased on the Adafruit blog. Oh, and there's one more thing. On Saturday the 27th, we'll be hosting our first Halloween costume contest live on Google Plus Hangouts. So don your getup, join the hangout, share your project, maybe even win something. Isn't it great living in the future?
All right, next up, it's not out yet, but this is where we're moving to. We'll be there very soon. Here's a beautiful photo from John Janier. This is just one of the many areas of the new Adafruit headquarters. We will be there very soon. Not out yet, don't ask. Let's keep moving on. Here is a project from Becky.
This is my Flora TV Be Gone. So here's the Flora on the back, and I'm using a tiny LiPo battery, and then just 2 IR LEDs, and then one of our little push buttons on the front, and a little fabric ruffle. and then the IR LEDs kind of stick up at the top, and it makes a little brooch. So when I push the button, you can see the flicker, flicker, flicker of the IR LEDs.
Oh yeah, look at that.
And you can wear it like a pin, like this, and then turn off the TVs at the restaurant.
Or turn them on.
Or turn them on.
Yeah.
More TV everywhere.
Okay, Lady Ada,
the project
what's going on
Lady
here
Ada.
with Flora?
Okay, well, first off, we're listening to Michael Jackson, and also I'm testing 2 products at a time. Wrapping up the Flora, finally, like, we fixed all these bugs, we got all working great, and I'm testing the I2C port, which is over here. There's power, I2C data, I2C clock, and ground, and I'm just wiring it up to this matrix to test it out, so you can see this nice blue matrix.
All right, when are we going to wire it up to Matt?
Right now.
Okay. There's no break?
Yeah, you're like the board. Poor Matt. Sorry, Matt.
You've been co-opted for the video.
It's all good. But yeah, the cool thing is it's portable and it's running from some AAA batteries. And yeah, this is working really well, which makes me happy.
Okay, great. Okay, Lady Ada, what's going on here with...
And here are the GPS, ultimate GPSs for Flora. Not out yet, don't ask. And here's a new product from Adafruit for the Raspberry Pi.
Okay, Lady Ada, what are you working on?
I'm working on adapting my super popular RGB character LCD shield from an Arduino to the Raspberry Pi.
Okay.
So, I've got my Pi in here in our 3D printed case. Ooh, nice.
It's a nice case.
Yeah, it's running Occidentalis with a Wi-Fi adapter. And then here's the prototype I have of the plate that I'm making for the RGB LCD. So we've got a character, pardon me, a 16 by 2 character LCD. And there's some buttons here, and I made this so I can remove it really easily because I'm testing out all sorts of displays. So let me run my example code. So it goes through red, yellow, green, blue, teal, violet, purple, and then you can press these left, up, right, down button, and that's how you can.
And then just to show, that's the Pi inside of the case that we're working on.
Yeah, I just decided to keep it in the case because we're doing testing on the case, and then bringing the cape out here.
Okay, so everybody happy Pi Day.
Happy Pi Day.
Okay. Okay, Lady Ada, what are you working on?
Next up, we're working on a new watch. This is kind of the first time we're going to show it. This is on my wrist. One of the things I like about this is you can tell what time it is.
It's 11:03.
Yeah, we're running a little late here. This is kind of like our take on like DIY watches. We thought, wouldn't it be neat to have a fun one that anyone can wear? There's big ones out there. There's not something that we think that kind of fits everybody.
Well, I want something that fit me.
Yeah, you want something that fits you, and something that also is very easy to program.
Yeah.
And I believe the Arduino team announced this might be part of the Arduino at Heart program.
Mm-hmm.
And basically, it's kind of like an Arduino programmable watch. And
it has a couple different faces, but this is the easiest one to read. The other ones are like binary watch.
Yeah, so we had this at Maker Faire, and it's really neat. I had a segment or an article series on Engadget called Watch This Wednesday because I have a geeky watch collection. It wasn't because I like geeky watches. I was doing research for like the past 10 years of what type of watch that I want. Okay.
Yeah, so do you want me to show this off at all? Oh yeah, show while you're getting the cat.
No, we still actually have a couple more things.
Oh really?
Yeah, we do.
Wow. Okay.
We still have another one. This is the Law of Robotics poster.
Oh, yeah.
Yeah, so this is going to be out pretty soon. What we wanted to do is have a cool poster with Adabot, and this is the Law of Robotics poster, and at the bottom it has...
The Laws of Robotics.
The Law of Robotics from Isaac Asimov, Handbook of Robotics, 56th edition, 2058 AD. So here it is.
Okay, so you'll be ready for 6 years ago when the robots rise.
Yeah, and it's a movie-sized poster. I think 18 by 24.
It's a classic poster. So.
Okay, and then go ahead and show the watch on the overhead.
Oh no, you have to do the trivia question, and then then I'll show it.
Oh, you want to do that?
Yeah. I'll do it while you're getting the cat.
Great, trivia question time. All right.
The prize is the bag of stuff.
Yeah.
It's a lot of stuff, guys.
We're giving away my goodie bag from...
you get an MSP 430,
you get
an oven mitt, you get a badge, you just get a lot of stuff.
So, the first person to type this into the chat that I see wins.
Yeah.
Our decision is final.
If you won something before, please don't enter, because we still want to make sure everybody wins something. So just sit on your hands, even if you don't
All right.
Let somebody else win.
Okay. What is the name of the art gallery / place that the Open Hardware Summit was held? First person to type it in. It's not Lulphil. Bad K, iBeam. You got it. Bad K, email support@adafruit.com, and you get this
totes
bag.
open.
Plus, people handed me a bunch of stuff that I don't know what it is, but it's in that bag too. So support@adafruit.com.
We want to make it easy because we knew it would be.
Yeah, and that is where the Open Hardware Summit and iBeam kind of a central touch point for all things open source hardware. You were there. GRL was there. Aya was there.
Aya was there.
It's like a mutant school for open source hardware.
It was.
So that's what it is. All right. So why don't you show the watch on the overhead?
Yeah, you go get this this cat. Okay.
And then we'll catch
so the
up
cool
to...
thing about this watch, this is the white version. The cool thing is that we use an off-the-shelf watch band, so we can get these watch bands, and they're meant for these like low-cost like gummy. They're called gummy watches or jelly watches. So it's a really nice silicone band, and then we just designed it to pop right in, and then on the back you see it was a coin cell. It's got a real-time clock, so it keeps time really well, and your kind of classic Arduino compatible microcontroller, and then there's 2 buttons, so you can set the time or show the time, and then let me see if I can change it to the binary watch. Yeah, so it's the binary watch. So I don't know how the heck you read this somehow. Anyways, it's like 11:05.
Yeah.
And then this fits right in.
Okay, so we should be back next week. We have a lot of stuff going on here at Adafruit. We'll let you know if the show is going to go on. It logistically is challenging next week for us. We have a lot of new and interesting things that we want to show and share. MOSFET will have this on him.
Model this watch.
Yeah.
I can model it.
You want to have him wear this watch?
I mean, he can. Well, I don't want to choke him.
Yeah, don't choke Mr. Cat. Not good. All right.
Okay, show the cat.
Yeah, it's time to show the cat.
Cat time.
Yeah.
It's interesting that it looks really good on a camera. Sometimes multiplex matrices do not look good.
Yeah.
This one looks good.
No, it looks...
Phil B did the code for this.
Yeah.
We're a good team.
Okay. That's it for the show. Special thanks to Becky, George, John Janier, Phil B, everybody at the Open Hardware Summit who did a fantastic job.
The cat.
The Open Source Hardware Association for fighting the fight, getting the word out about open source hardware. Everybody who contributed to E for Electronics Coloring Book, everyone at Maker Faire.
K-Town.
Who was there and said hi to us. And all of our staff who came in.
Yeah, it was crazy.
Yeah. And we will hopefully see everybody next week. We'll keep you guys posted. Boy, that was a big show. Sorry we didn't get to questions. We just had to get through all the stuff because we're 2 weeks behind.
We had 2 weeks worth of show.
Yeah. We'll see everybody very soon. Here is your moment of Zener.